Hello everyone. Uh, my name is Sahil and my colleague Julie. We are going to introduce minimal APIs. We are covering the topic Introduction to Minimal APIs, Basic Principles of Minimal APIs, Choosing the Right Technology Stack, Real World Use Cases and Examples. And over to Julie. She will be starting with introduction of minimal APIs.
So let's start with introduction to minimal APIs. So minimal APIs are designed to be straightforward and easy to understand. They typically have clean, concise syntax and avoid unnecessary abstractions or complexities. Next is focus functionality. Minimal APIs focus on providing only the essential functionality required to solve a particular problem. They avoid feature bloat and prioritize delivering a streamlined solution without unnecessary bells and whistles. Lightweight design. Minimal APIs aim to minimize resource consumption and overhead. They often have low memory footprint and fast execution speed, and minimal dependencies, making them suitable for performance sensitive applications. Over to you, Sahil sir.
Flexibility. Despite the simplicity, minimal APIs are often flexible and adaptable. They can be easily customized or extended to accommodate different requirements and use cases. Developer productivity. By reducing complexity and boilerplate code, minimal APIs can improve developer productivity. They allows developer to focus more solving business problems and less managing infrastructure or dealing the unnecessary abstractions. Scalability. Minimal APIs are well suitable building scalable applications as they can be easily scaled horizontally or vertically without introducing additional complexity. They are often use microservices architecture and cloud native applications. Over to Zuli.
Let's see the basic principles of minimal APIs. The principles of minimal APIs revolve around simplicity, minimalization, and a reduced ceremony in comparison to traditional ASP.NET applications. First is conciseness, means short and clear. Minimal APIs prioritize brevity and conciseness in code. Developer can achieve more functionality with fewer lines of code, reducing verbosity and boilerplate. Top level code. Minimal APIs often define a single file, typically in program CS. This top level code approach allows developers to see and understand the entire application at a glance. Next, convention or configuration. The framework encourages the use of convention where default configuration and behaviors are inferred based on the structure of the code. This reduces the need for explicit configuration. Next, direct routing. Routing in minimal APIs is simplified. Endpoints are directly mapped using the endpoint.map method, making the routing logic more straightforward and readable. Minimal boilerplate. Minimal API aim to minimize boilerplate code. Developers can focus on writing business logic without the need for extensive setup or configuration files. Over to you, Sahil sir.
Dependency injection. Dependency injection is still a fundamental part of minimal API. Services can be registered and injected, promoting modularity and testability in the code. Declarative syntax. Minimal APIs often use a more declarative style where developer express what they want to achieve without specifying the exact steps or process. Flexibility and extensibility. While minimal APIs provide simplicity, they are designed to be flexible and extensible. Developer can extend functionality as need with sacrificing the overall simplicity of the framework. Async support. Minimal APIs fully support asynchronous programming pattern. Asynchronous delegates can be used for handling request and response, allowing for non-blocking operation. Readability. Code readability is emphasized. Minimal APIs aim to be easy to understand, making it simpler for developer to comprehend and maintain the code base. Integrations with the existing code. Minimal APIs can coexist with the traditional ASP.NET Core MVC application. This allows developer to choose appropriate approach for different part of the project. Tooling support. Minimal APIs are supported by .NET CLI and Visual Studio tooling, providing in familiar and efficient development environment. Focus on APIs. Minimal APIs are particularly suitable for creating lightweight APIs. The framework is tailored to the needs of API development, focusing on delivering data and service over HTTP. Documentation. Document is an integral part of minimal APIs. Tools like Open API and Swagger can be integrated for easy exploration and testing of the tool. These principles collectively contribute to the physiology of minimal APIs, offering developers streamlined and efficient approach to building APIs in .NET. They can promote a development experience that values simplicity, readability, and flexibility. Over to Zul.
Okay, so Kiran is asking, how do I create a minimal API in .NET? So, you can create minimal API using the web application class in program class. This involves using a combination of routing and endpoint declaration directly in the program.cs file without the need for separate startup class. Uh, Next is choosing the right technology stack. When selecting a technology stack for building minimal APIs, it's essential to consider factors such as performance, scalability, developer familiarity, ecosystem, support, and specific requirements of your project. First is programming language. Choose a programming language that aligns with your team's expertise and the requirements of your project. Popular choices for building minimal APIs include in JavaScript and TypeScript, Node.js with frameworks like Express.js, in C Sharp, ASP.NET Core, in Python, Flask, and Fast API, in Java, Spring Boot, and Spark Java. Consider factors such as performance, community support, and ecosystem when selecting a programming language. Next is a framework or library. Choose a lightweight framework or library that provides the necessary features for building minimal APIs. Look for frameworks that offer simplicity, flexibility, and performance optimization. Example includes Express.js in Node.js, Flask in Python, Fast API in Python, ASP.NET Core in C Sharp. Evaluate the documentation, community support, and the ecosystem of each framework to ensure it meets your project requirement. Next is database. Select a database that suits your application's data storage and retrieval needs. Consider factors such as data structure, scalability, performance, and developer familiarity. Common choices include relational database like MySQL, SQL, MongoDB, and SQLite. Choose a database that integrates well with your chosen programming language and framework. Next, authentication and authorization. Determine the authentication and authorization mechanism required for your API. Consider using lightweight authentication libraries or middleware to handle user authentication and authorization. Look for solution that supports common authentication methods such as JWT, that is JSON Web Token, or OAuth. Ensure that chosen authentication mechanism aligns with your security requirements and regulatory compliances. Over to you, Sahil sir.
Deployment and hosting. Choose a deployment strategy and hosting platform that suits your project needs. Consider options such as self-hosting on virtual private server, VPS, deploying to cloud platform like example like AWS, Google Cloud, Microsoft Azure, or using serverless architecture. Evaluate factors such as scalability, cost as of deployment, and management overhead when thus selecting a hosting platform. Monitoring and logging. Select tools and service for monitoring and logging to ensure the reliability and performance of your API. Consider using monitoring tools such as Prometheus, Grandfa, and Datadog for real-time monitoring of server metrics. Implement logging solutions such as ELK Stack, Flute, and Paper Trail or for collecting and analyzing application logs. Testing and continuous integrations, continuous deployment (CI/CD). Choose the testing framework and CI/CD pipeline to automate the testing and deployment process. Use testing frameworks like Jest, JavaScript, PyTest, Python, and Unit C Sharp or JUnit Java for writing unit tests, integration tests, and end-to-end tests. Set up CI/CD pipeline using tools like Jenkins, GitLab, CI/CD, or GitHub Actions to automate building, testing, and deploying your API. By carefully considering these factors and evaluating the available available options, you can choose technology stack that aligns with your project's requirement and enables you to build robust, scalable, and efficient minimal APIs. Real-world use cases and example. For example, in an e-commerce platform, you might have a separate microservice for use or authentications, product catalogs, order management, and payment processing, each with its own minimal APIs. Over to Zwingli.
Next is in real world example, webhooks and event driven architectures. Minimal APIs are often used to implement webhooks and event driven architectures, where services can subscribe to events and receive notification when specific event occur. For example, a messaging platform might expose a minimal API for registering webhook endpoints, allowing external services to receive notification when new messages are received, users join conversation or other events occurs. Over to you, Salsar. There are some questions.
Yeah, we are
Okay. Pooja is asking what is the benefits of minimal APIs.
Meghna is asking, I think, can I use dependency injection in minimal APIs? Yes, dependency injection is still available in minimal APIs. You can use the add singleton, add scope, or add transit methods on the web application instance to register services. I think Ankita is also asking soap and Rust.
Meghna is also asking what is the role of the endpoints class in minimal APIs. So, the endpoints class is often used to configure endpoints in minimal APIs. It provides a more structured way to define endpoints, especially when the API grows in complexity.
Okay, we are done with the questions, Zwili.
Yeah.
Okay, do follow Work Labs and subscribe and press bell icon also. Thank you.
Thank you.